Welcome to our YouTube channel. This is Dr. Sengolrajan, Associate Professor in the Department of Electrical and Electronics Engineering from Kunganadu College of Engineering and Technology, Kottayam, Tiruchirappalli. Now we are going to discuss about finite state machine model that is being called as FSM model in embedded systems. Then, what is FSM model? You can call it as state machine model or a finite state machine model. An example for finite state machine model we are going to illustrate for the concept is the example which we are going to take is an FSM model for coin operated telephone system. As you are aware that a coin drop telephone coin machine which is being kept at the hostel or at the college premises or at the road shops, you may aware, but you may not aware how it is being working based upon this FSM model or this finite state machine model, how it can be interrelated with the coin operated telephone system. Let me interrelate the finite state machine model with the coin operated telephone system. There are around state A is the first state 1, state B 2, state C 3, state D 4, state E 5, state F 6, and state 7, that is 7 steps. 7 steps, then finally an 8. So the entire coin operated telephone system interrelated with the FSM model can be illustrated its state using an 8 steps. So we are starting the state from A and we are ending with I. Let the state A is taken it as ready and state B as wait for a coin. Wait for a coin. State C, wait for a number. Wait for a number. Then state D, dialing. State E, call in progress. State F, call terminated. State G, unable to make call. State H, invalid number input. State I, out of order. Let me illustrate the steps with the state sequence. Let first we are taking it starting from state A. You are taking the lever. You are taking the lever, pressing the lever hook, and you are taking the lever, taking the lever. That is your event. That is not even, it is event. It is a event. You are lifting the receiver. The action is okay. Then comes state B. You have to next step. Once you take the receiver, the hook, lifting from the lever, you have to insert a coin. That is the event is nothing but a coin inserted and the action is okay. Coin is inserted. Then what do you have to do? You have to enter a number. That number should be a valid number of 10 digits. So you are entering a number, a valid number. That is the event. From state C, you are entering the valid number, and if it is valid number, the dial will goes from state C to state D. Suppose if the number is an invalid number, or if there is a line BC, the line will be BC means it instead of going from D to E, it will goes to state G, that indicating the event is line fault, or it may be a line BC, or you may type an invalid number, but action is display error, display error, line fault, line busy or invalid number. The display will be, the action will be display error, and it goes from state D to G, and from G, the event place receiver. You have to place the receiver. Then again, what you drop an 1 rupee coin, the coin will come back. When it comes to state A, then it is goes from state A to I, indicating event line fault. Event line fault action is display. Action is display. Suppose you may enter and valid number, and action is dialing from state C to D. Then D, you may have an event. Line is available. Line is available. Then you can speak to the end user, end user, but thing is you have to monitor the time. You have to monitor the time. Or if you drop a coin, a 60 seconds is allotted for a coin that is inserted, for a one coin that is inserted. At the 45th second, it will wait for a another whether you want to continue, or you may end up with 60 seconds. So that is the thing you have to monitor. Then from state E, if it is time out, 60 seconds out, you are not dropping a coin at the 45th second, 45th second, the action will disconnect at 60 seconds. Okay, 60 seconds. Suppose if you're not dropping and another coin at the 45th second, line will continue. Line will continue. You may speak it. After speaking, then you may place the receiver. Then action is done. Or else, or else, or else, if you are not dropping a coin at the 45th second, but you are keeps on continuing even after 60 seconds, the line is disconnected. You have to place here, place the lever. Then it says error, event line OK, event line OK, and display also OK. Then it is says out of order, out of order. So this all the sequence, all these eight sequence are explained using and state starting from state A to state I for a coin operated telephone systems. Telephone systems. So this is a design of a coin operated public telephone unit based upon FSM model. FSM model. Let me use more explanations on this stage. If you want to design a coin operated public telephone unit based upon FSM model, the following requirements are required. That what I said earlier in the previous slide with the diagrammatic step, the same thing I am repeating once again. The first step is calling process is initiated by lifting the receiver off hook of the telephone unit. That is a first step. You have to initiate the call by lifting the receiver of the telephone unit. Second step, after lifting the phone, the user needs to insert an 1 rupee coin to make the call, or to initiate a call. Suppose if the line is busy, the coin is returned on placing the receiver back on the hook, or suppose if he dialed a correct number, and the dial is continued, he may have a line and he is allowed to speak till 60 seconds. But at the end of the 45th second, if you want to continue the call, he wants to add another 1 rupee coin for continuing the call to be initiated. To be initiated. The user does not drop on 1 rupee coin at the 45th second, the call will be terminated on completing the 60 seconds time slot. The system is ready to accept new call requests when the receiver is placed back on the hook, or the system goes out of order. There will be an indication, a line fault. Most of the time, state machine translates the requirements into sequence driven program, and it is difficult to implement in concurrent processing with the finite state model. That means most of the time the state machine model is interrelating with the time, and it is translating what the requirements into a sequential driven program. But writing and sequential driving program is difficult to implement for a concurrent process model with the finite state machine model. Finite state machine model. So in that case, you can go with an HCFSM model, that is called hierarchical or concurrent finite state machine model. You can call it as HCFSM, that is hierarchical concurrent finite state machine model, is an extension of the finite state machine model for supporting the concurrence of a sequential flow as well as the hierarchy. The HCFSM continues or extends to the conventional state diagram by illustrating with and or logics with the decomposition of the states coupled together with the interlevel transitions and for broadcast mechanisms for communicating between the concurrent processes. It uses the state charts for capturing the states, transitions, events, and actions. So, finite state machine model is explained using an public operated telephone coin system, and this FSM model, which has an advantages to be continued, it states with an illustration of HCFSM model, and whereas the concurrent model is not to be more advantageous, but FSM model is to be advantageous, and it can be continued with the HCFSM model. The state charts you can be able to represent using the geometric shapes like a round, rectangle, ellipse, or circular. But the hard state chart uses a round rectangle for representing the state. There is a procedure how to represent the state, that you can represent using a round rectangle, or you may go with a rectangle, ellipse, or circular. But the arrow marks is used to represent the state transition, where the state is associated with another state transition. An optional parenthesis condition can also be labeled with an arrow mark such that the state sequence transition flow can understood and the occurrence of specific event. So you may use a lot of design tools that is available for the state machine and state-based system modeling. Here comes and ended with an explanation of finite state machine model using a public operated telephone unit. Here, the IER visual state from IER system is a popular visual modeling tool for the embedded applications. Let me see in the another video of my YouTube channel. Thank you. Here ended up with an finite state machine model.